Hi guys, am I audible? If I'm audible, give a response in the chat box so that I'll know who all are there in the session as well. Great. Whoever is there in the session, just leave a message in the chat box so that I'll get to know who all are there in today's session. Great. Gaurav, Rohan. Hi Kiranmai. Hi Sandeep. Okay, so I think we can begin the session. So today's agenda is to discuss 10 questions which are going to be slightly tougher. They will not be level 1 questions like we discussed in the previous session. They're going to be slightly tougher. And they are going to be mainly tough because you don't have too much time. Your concepts have to be absolutely clear to be able to solve those questions within the given time in the quiz. So as usual, we will also have a live quiz which is going to go parallel to this session. So if you're there in the live session, please do take the live quiz. You can find the link, the first link in the description of this video. So click that link, go there, and you'll be able to find a quiz named time and work level, time and work live quiz. Click on that and we'll be attempting one question there, coming back here and discussing it, going back, attempting. So it will be up and down between the quiz page and the discussion page. So that's how it's going to be. Okay, someone is asking, are these questions of snap level? Okay, with the latest format of snap, which goes like 60 minutes, 60 questions are likely to be easy. Today's questions are slightly going to be on the tougher side. So I would say it is in between snap and XAT level. Okay, some questions could be of XAT level also. Okay, so they are definitely not perfect level 1 questions. They are slightly tougher than level 1. If you are very clear with the concepts, you will be able to solve within the given time. If not, you might find yourself struggling to complete the question within the given time. Okay, so that's how we are going to go about it. So I hope all of you have visited the quiz page. The quiz page link is there in the description. I'm going to start the quiz. So we are going to do it parallel. So we'll be attempting a question in the quiz. We will come back and discuss and so on. We'll also have a live leaderboard going on here. In case you are going through this video as a recorded video and you were not there in the live session, you will still be able to follow along because the questions will keep flashing here. And you will also see how much time is given for each question. You could just time yourself accordingly and see whether you're able to solve the questions within the given time. So let's start the quiz. I'm going to start the first question in the quiz. The first question is up in the quiz and it's also up on your screen here. I'm going to wait for the on-screen timer to come to 0. Some of you might have seen that in the real quiz, the time is already 0. I started the leaderboard on the screen a little late. So we'll wait for the on-screen timer to come to 0. Perfect. Let's see what is the status of the leaderboard after you guys have attempted the first question. Very good. The entire leaderboard is filled with marks. There is no 0, which is a good sign here. Many of you have got it right. At least more than 10 of you must have got it right, I believe. Let's see how we can solve this question. As I said, your clarity should be, you should have absolute clarity to be able to solve these questions and to solve them quick. So let's see how we can approach this question. It shouldn't take much time to solve this. A contractor decided to complete a work. Just give me a minute. Yeah. A contractor decided to complete a work in 60 days and employed 60 men at the beginning and 30 men additionally after 20 days and got the work completed as per schedule. Great. If he had not employed the additional men, how many extra days he would have needed to complete the work? Okay, so how many extra days if he had not added that extra men? So what I'm going to do is I'm just going to see how much work those extra men did during the entire period. So if you see, it's given that after 20 days he added, right? 30 men additionally after 20 days. So for how many days these 30 men were added? They were added for 40 days because the target is to finish it off in 60 days. So after 20 days, if 30 men are added, then those 30 men worked for 40 days and those were the extra men who were added. So the extra work that was done by those extra men is 30 into 40 units. If I'm going to assume each man does 1 unit in 1 day. Now, if this was not done, if that extra work was not done by those extra men, then this work must have been done by our regular 60 men. So if they do this divided by 60, I can find out how much extra days they will take to do the extra work. So what I have in the numerator, let's just cancel this. This is 2 times, 3 times, 10 times. We will get 20 as the answer. So 20 days would have been extra if those 30 men were not added after 20 days. Please type 20 if you're clear with how we got the answer as 20 for this question. And I haven't been very explicit in what I'm explaining. So it's absolutely okay if you want me to explain in detail. Please type D if you want me to explain this with greater detail. If you're clear already, please type 20. Please don't shy away from asking me to explain in detail. I'm intentionally skipping certain basic explanations. If you're asking me to explain in detail, absolutely fine, no issue at all. Okay, let me quickly go through this with greater detail. Okay, so let's see what we have done here, because initially I tried to do this because I want to show you what actually happens in an exam. In an exam, someone who's thoroughly prepared will only do this. Okay, he will look at this 30 men after 20 days. So 40 days, 30 men. Okay, so 40 into 30 divided by the original men by 60, 1200 by 60, 20 is the answer. So he would actually solve it in 30 seconds or less. Okay, but let's try to understand this at a greater detail here. So what's happening is it was planned to complete the work in 60 days, right? So this is the actual plan, and 60 men were employed to do that work. But what happened is after 20 days, 30 extra men were added. So let's say after 20 days. So from here on, some extra men were added. So already 60 men were there. Along with that, from here on, another 30 men were added, and hence the work got completed in 60 days. So it's very clear, if those men were not added, it would not have got completed in the required period of 60 days, right? So now they're asking us to find out if those extra men were not added, if he had not employed the additional men, how many extra days it would have taken. So for that, what I'm trying to do is I'm trying to find out work done by the 30 men. The extra men who were added, how much work they did. So they were added after 20 days, right? So they were there in the work for a period of 40 days. So if I assume each of the men who's here, if I assume each of the man who's here is going to do 1 unit in 1 day, then these 30 men for 40 days would have done 30 into 40 units. That would definitely not have got done if we had not employed those extra 30 men, right? Because they were there only, they did this 30 into 40. So if those 30 men were not employed, then by the end of 60 days, whatever work they did would have remained as remaining work, right? So the work done by 30 men would have got pending by the end of 60 days if they were not added after 20 days. So from there, it would have taken some more time, obviously, because some more work is pending. And who's going to do that extra work? We have the 60 men only. There is nobody else to do that work. So if those 60 men were to do the pending 30 into 40 units, so I can just divide by 60 because we are assuming that each man is capable of doing 1 unit per day. So 60 men will do 60 units per day. So if I just cancel this, 30 into 40 is 1200 by 60. Units will get cancelled. I will get 20 days as the answer for this question. I hope it's clear to everybody now. Please type C if everybody is clear with how we got the answer as 20 days for this question. Perfect. Let's move to the next question. I am going to move to the next question in the quiz. Those of you who joined us a little late, please click the first link in the description. You'll be able to take into the dashboard of our website where you can see a live quiz that is going on. Of course, only if you're there in the live session. If not, you'll have to just follow along with what you see on the screen. If you're there in the live session, then please head to the quiz page. I'm moving to the second question in the quiz. The second question is up in the quiz and it is also up on your screen here. Okay, just give me a minute. Just give me a minute. Maybe just give me a minute, guys. I know what happened. We faced this one more day. If you remember, we had a general knowledge quiz which was open and that kind of messed up with the current quiz. So I'm going to end it, guys. It's going to come sorted now. Just give me a minute. Just give me a minute. I'm going to restart the quiz. Can you guys please refresh your page once? Is everything fine now? Please refresh your page once. Just tell me if everything is fine. Yeah, it should not happen. We had a current affairs quiz today that was open in another tab. I think that was interfered. The status of that quiz was interfering with the status of this quiz. It should not happen after this. Good. Bharat remembers what happened the other day with the GK quiz. Same thing. Today we had the current affairs quiz. It was opened in another tab. Thirty more seconds. Not able to attempt this question. Okay, maybe from next question it should be activated again. Maybe this question, because something happened, there could be some issue. Great. Let's see how we can solve this one. There is some change in the leaderboard. Some of you were not able to attempt, so it might not reflect the actual state of this. That's okay. Let's see how we can solve this question. So first I'm going to solve like I'm sitting in an exam. So I'll not be giving too many explanations. I'll just be giving minimal amount of explanations for the first round of solving. Then if you want me to explain, I will definitely explain in detail. So first, let's see. A and B completed a job working together in Y days. A takes Y plus 8 days to complete the job. B takes Y plus 18 days. Okay, so together they take Y days. A takes Y plus 8, B takes Y plus 18. There is a formula for this to find Y. So Y is going to be square root of product of the x's, which is 8 into 18. 8 into 18 is 144. Square root of 144. Y is going to be 12. This is something that I've discussed in the concept class. So Y is equal to 12. So when Y is equal to 12, I can find out what is the time taken by A and what is the time taken by B. So let's put that down. So time taken by A should be 12 by 8. So number of days, it will be 20 days. Time taken by B will be 12 plus 18. That will be 30 days. So for any work, their efficiencies will be in the opposite of the time ratio. So time ratio is 2:3. So efficiency ratio, I can say it's going to be 3:2. Now, if B takes 90 days to finish, so if B takes 90 days to finish another job of the same kind, how long will A take to finish? I could just go with this itself. For instance, here if you see, B is taking 30 days to finish a job while A takes 20 days. So what I can do is, if B takes 90 days, then A with his regular efficiency should take 20 into 3, 60 days. When B takes 90, A should take 60. That's a regular efficiency. But they have given how long A will take if he is working at half its efficiency. Regular efficiency, A will take 60 days. Half the efficiency, he will take double the number of days. Right? So 60 into 2, 120 should be the answer for this question. Please type 1 if you're clear with why we are going with option 1 as the answer for this question. Okay, now coming to this part, this is a particular concept that I've discussed in the concept classes in detail. So I'm quickly going to brush that up for those of you who might not have gone through the concept class that we have discussed. So what happens is, whenever you have, let's say A, B, and time taken by A and B. Okay, let time taken by A and B be T. Let time taken by A be T plus A days. Definitely A will take, when working alone, he will take little more than what they took working together, right? And let's say time taken by B is given as T plus B days, right? Time taken by both of them is T. Time taken by A is T plus A, that excess I am calling A. Time taken by B is T plus B, the excess time that B will take is B. So what I can do is, I can relate all of them, because I can get their efficiencies, and efficiency of A and B, when I add, that should be equal to efficiency of A and B working together. So what I can do is, efficiency if I take, I'll get 1 by T plus A. If I add that to 1 by T plus B, that should be equal to 1 by T. Now, if I'm going to simplify this, I'm not going to do it right now. If I'm going to simplify this, I will finally get T is equal to square root of AB. I would suggest strongly that you try to remember this result. Okay, please remember this result. I have directly applied that result here, got the value of Y, hence got the value of A and B. From there, if B takes 68, sorry, if B takes 90, then A will take 60. That is the normal efficiency, half the efficiency, double the time. So 120 is the answer. I hope it's clear for everyone now. Please type C if everybody is clear with this question. Perfect. Let's move to the next question. Before that, I'm just going to remind you at multiple times during the video, if you haven't liked this video and if you like the way the session is going, please do like the video. It helps us to reach more people. And if you haven't subscribed yet, please do subscribe and click the bell icon as well so that you'll receive notifications of the sessions that we do. Okay, let's move to the third question in the quiz, guys. Wait, just tell me, is it still are you still not able to give your answers? If you're facing problem, please tell me. I think it should be sorted, whatever problem you faced earlier. And I am going to the third question here on the screen as well. For those of you who are solving, looking at the screen. Fine, great. Looks like the time is up. Let's see the status of the leaderboard after you guys have attempted this question. There's some change. Swati on top, followed by Subhashish, Gaurav, Pranay, Rohan, Bharat, Bhargav, Sandeep, MSD, and Triveni. Let's see how we can solve this question. 64 men working. Just a minute. Okay. 64 men working 8 hours a day plan to complete a piece of work in 9 days. Okay. However, 5 days later, they find that they had completed only 40% of the work. They now wanted to finish the remaining portion of the work in 4 more days. Okay. How many hours per day should they need to work in order to achieve the target? Okay. So I'm thinking we can go through input-output approach here because there are multiple parameters: men, hours, days, work. So I'm going to put columns for all of this and solve. So let's start with men. So that's one column. Number of hours that they're going to work is another column. Number of days for which they're working is another column. And the amount of work that gets done is the fourth column. So 64 men working for 8 hours a day plan to complete. So they did not exactly complete in 9 days. They plan to complete in 9 days. However, after 5 days, they realize. So probably they worked for 5 days at a rate of 8 hours per day and completed only 40% of the work, right? So only 40% of the work got completed. Now they now wanted to finish the remaining portion of the work in 4 more days. So 4 more days and the remaining portion is 60%. And there is no addition or removal of men. So same 64 men, we'll have to find out how many hours they will take. So as per input-output approach, time and labor will be classified as input. So in this case, if I see this is labor, so that's input, hours is time, that's input, days is also time, that's also input. The work that is getting done is the only output. So what I can do is product of all inputs by product of all inputs in the next case, that is product of inputs in the first case by product of inputs in the second case, should be equal to output in the first case by output in the second case. So this should be equal to 40% by 60%. If we just simplify that, we'll get the value of question mark. Let's do that. So let's start cancelling things out here. So 40 and 60, that's going to be 2 and 3. 64 and 64 will be out. This 4 into 2, this 4 will go on the other side. So 4 into 2 will cancel this. 8, question mark goes that side, 3 comes this side, we will get question mark as 15. That tells that these guys should be working at a rate of 15 hours per day. So answer is 15 for this question. Please type 3 if you're clear. Type D if you want me to explain at a slightly greater detail. Just waiting for responses from the people in the live session. Perfect. Let's move to the next question then. I'm moving to the next question in the quiz. The next question is up in the quiz and it is also up here on your screen. Okay, the time is up. Let's see the status of the leaderboard after you guys have attempted this question, question number 4. Still Swati on top, followed by Bhargav, Subhashish, MSD. Some of these guys are coming up in the leaderboard. Let's see who will end on the top in the end. Okay, let's see how to approach this question. To do a certain work, R alone takes thrice as long as P and Q together. Okay, so time-wise, R takes 3 times the time. So I can say efficiency-wise, P and Q are 3 times as efficient as R because time and efficiency are inversely varying, right? So R alone takes thrice as long. So I would say efficiency-wise, I'm only calculating efficiencies right now. So efficiency-wise, I can say efficiency of P and Q by efficiency of R should be in the ratio 3:1. Right? I can just do +1 on both sides, or I can just take P plus Q as 3 units, R as 1 unit. So P plus Q and R, all 3 of them will be 4 units. R's is 1 unit if all of them will have a total of 4 units. So I can say efficiency of R is 1/4 of total efficiency. Total efficiency is basically P plus Q plus R. Okay. Similarly, if I go for the next statement, P alone would take twice as long as Q and R. Time wise, P takes twice. So efficiency wise, Q and R should be twice. So efficiency wise, I can say Q plus R by P should be in the ratio 2 by 1. Here again, if I'm going to take that, if Q plus R's ratio is 2 parts, then P is 1 part. So sum of all of them will be 3 parts, of which P's is 1. So I can say P's should be 1/3 of total. Okay, so R's is 1/4 of total efficiency, P's is 1/3 of total efficiency. So it will be better if I take a value for total, which is a product of 4 and 3, so that I'll get proper values for R and P's efficiency. So let's take LCM of 4 and 3, 12. I'm going to assume that to be the total efficiency. So if I take total efficiency as 12 units per day, then I will get R's efficiency as 3 units per day and P's efficiency as 4 units per day if I want to calculate that. I can find out what is Q's efficiency also, because total is 12. These two guys are 3 and 4. So 3 plus 4, 7 is already out. Another 5 units is left. That should be P's efficiency, if that is required. I don't think it's required for this question. Let's see what they're asking. All three together complete the work in 3 days. Okay, together if these guys are working, they are capable of doing 12 units, right? At that rate, they are taking 3 days. So then what is the total work? 12 into 3, which is 36 units. That is going to be the total work. Now, the question is, how long will P alone take to complete the work? If P alone is going to work, he is going to work at a rate of 4 units per day, right? But the total work is 36 units. So if P alone is going to work 36 divided by 4, he should take 9 days to complete the work. Okay, so now there are certain calculations here which I have done, which are not necessary for this question. I'm just trying to show you how to find individual efficiencies, but you need not do all of that. Okay, all that you can do is you can just look at this itself. P's efficiency is 1/3 of total, or if total is 4 parts, P is 1 part. From there itself you can find out if total work is 36 and if they're taking 3 days, P will take 3 times of that. Okay, because just look at this ratio. So we'll get the answer as 9. So these are all certain calculations that I'm doing to show you what is happening here. Please type what is answer. 1 if you're clear with why answer is option 1 for this question. Okay, so what I'm trying to tell here is you need not do the entire calculation. Once you have seen that, how long will P alone take to complete the work? Once you have got P efficiency is 1/3 of total. So you can directly say something like this. Efficiency of P by total, when you're doing efficiency of P by total is 1 by 3. Right. So when you go for time taken, it will be 3 by 1. So time taken, if I go for P by total, it will be 3 by 1. They have given all 3 took 3 days. So if total is 3, then P's will be 3 into 3, 9. There itself you could have solved. Okay, we need not find out each one of them, but I'm just trying to show you so that in future, if you get a question with some kind of combinations, you should still be able to handle it. Okay, please type C once again if you're clear with how you could actually just do this. And that's what is necessary in the exam. The rest of it is not necessary for this particular question, but it will help you later for some other question. Perfect. Let's move to the next question, guys, in the quiz. The next question is up in the quiz. I'm going to activate it here on your screen as well. Okay, so this is the next question. This is question number 5. Raj, you can see the question on the screen, Raj. Raj is asking what's the question. You can see the question on the screen. Okay, time up. For those of you who might have joined a little late, you can also click the link, the first link that you see in the description, to take the live quiz. There is a live quiz going parallelly in our website. So if you're there in the live session, I would suggest that you take the live quiz so that you know where you stand with respect to the competition. Okay. And if you're watching the recording, you can obviously go through the question that is flashing on the screen. So let's see how we can solve. And before that, let's see the status of the leaderboard. Okay, I don't see much of a change. Let's see how we can solve this one. Babita can finish a piece of work in 48 days, working 9 hours a day. Raina can finish the same work in 36 days, working 16 hours a day. In how many days can they finish it working together for these many hours a day? So what I'll do is I'll convert everything in terms of hours. Okay, so let's say Babita and Raina, I'm converting everything in terms of hours. So for 48 days at a rate of 9 hours a day. So let that be 48 into 9. Total number of hours that Babita will take to finish the work. And Raina can finish the same work in 36 days, 16 hours a day. So that's 36 into 16. I can take LCM of these two and assume that to be the total work. But these are looking like dirty numbers. So let me see what all are common to these two numbers. Both of them have a 9. Both of them also have 16. So let's just rewrite them. So I can rewrite this as 3 into 16 into 9. I can rewrite this as 4 into 9 into 16. So 9 into 16 is common in both the places. This has got 3, that has got 4 as the difference. So our LCM is going to be the difference 3 into 4 and then whatever is common, which is 9 into 16. Now if we calculate the efficiencies, LCM divided by this. So this did not have 4, so this should be 4 when I divide this by 3 into 16 into 9. And this one did not have 3, so it should be 3 here when I divide this by this. So their efficiencies will be 4 units and 3 units if the total work is taken as this much. Now these are efficiencies per hour because we have taken hour here. So efficiency is in terms of units per hour. Perfect. Now what we're asking is to find out, in how many days can they finish it working together for these many hours? Okay, first of all, if they work together for 1 hour, they'll be able to finish 7 units. So their combined efficiency is 7 units per hour. But they are working for 7 5 by 7 hours in a day. Right. So that will be how much? 7 into 7, 49, 49 plus 5, 54 by 7. So per day, they are working for 54 by 7 hours. So these many hours per day they are working. So eventually, if I multiply this, I will get how many units per day they are going to do. Okay, number of units per hour into number of hours for which they are working in a day. Okay, now what are we supposed to do? We are supposed to find out how many days they will take to finish. So their efficiency right now, I can cancel this and say 54 units per day. Total work is these many units. So I'll have to just divide total work by their efficiency. So let's do that. If I divide this by 54, so 9 will cancel this. I'll have a 6 here. I can cancel the 6 with 3 and this will become 2. So 2 into 16. It tells me they will take 32 days to complete this. So answer should be 32 for this question. Type 4 if you're clear with how we got answer as 32 for this question. Type D if you want me to explain this at a greater detail. I think it was pretty fine. There was no skipping of any step or anything. But if you still want me to explain at a greater detail, please type D. I will explain. Great. Let's move to the next question then. I'm moving to the next question in the quiz. The next question is up in the quiz and it's also up on your screen here. It looks like the time is up. Let's see the status of the leaderboard at the end of your attempt of this question. Great. Not much of change on the top. There's some change at a later stage. Let's see how we can solve this one. 12 men and 15 boys can do a work in 6 days. 10 men and 24 boys can do the same work in 5 days. In order to complete the work, so two combinations they have given, right? 12 men and 15 boys, how many days? 10 men and 24 boys, how many days? In order to complete the work in 3 days, how many women should join a workforce of 8 men and 30 boys if it is known that a man can work twice as fast as a woman? Okay, first let me solve like how I would solve if I'm sitting in the exam. So 12 men and 15 boys. I'm going to take efficiency of a man as M. So 12M plus 15B is efficiency of a boy. This into 6 is equal to total work. And another combination is given 10 men and 24 boys. So 10 men and 24 boys. If they work for 5 days, that's also equal to total work. So I can actually equate the left hand side because right hand sides are equal. If we equate and try to cancel, let's see what is happening with M. So 72M, 50M. So 22M more will be there on one side. And that should be equal to how many B's? 6 into 50, 90B. This is 120B. 90B, 120B. That is 30B. So I will get 22M is equal to 30B, or I could probably write it as 11M is equal to 15B. That's how you can convert efficiency of a man into efficiency of a boy, or vice versa. Okay, now what are we supposed to do? We are supposed to find out how many women should be added for a particular combination. What is the combination? That combination says in 3 days the work should be over. Okay, and we have 8 men and 30 boys. So 8M plus 30B. I'll have to find out how many women I'll have to add. So I'll just put a dash here so that the same work gets over. It's the same work. So what I can do is I can convert all of them in terms of one variable, because too many variables going around here. So I'm going to convert all of them in terms of, let's see which variable. So we have got 11M is equal to 15B. I've got 15B here. So I think it will be easier to convert that in terms of M. I've got 30B here. So that's going to be easier again to convert in terms of M. So I've decided that I'm going to convert everything in terms of M here. So let's do that. 15B is equal to 11M. So this I can write as 11M. So this left hand side will become 6 into 12 plus 11, that is 23M. That is total work. So I can put that here, 6 into 23M. And this 30B also, if 15B is 11M, then 30B is 22M. I can replace this also with 22M. So now let's try and cancel whatever can be cancelled. Let's first get rid of this 3. So I can cancel this 3 with this, it becomes 2. So that tells me I'm supposed to have 46M. But what do I have here? I have 30M plus some women are supposed to come. So 46M is equal to 30M plus something. So if I were to put it in terms of M itself, then this would have been just 16M, because I have 46M on the right hand side. Right. So if I were to put in terms of M, it would have been 16M. But it is given a man can work twice as fast as a woman. If a man can work twice as fast as a woman, then in terms of number of women, we need twice the number of women to complete the same work that the given set of men can do for a given time. Right? Men are twice as efficient as women. So if I have men, then I require 16 men. If it is women, then I need double the number of women. Into 2, that tells me 32 women should be there in this workforce. So 32 should be the answer for this question. Please type 1 if you're clear with why we are going with option 1 for this particular question, or how we got the answer as option 1 for this question. Okay, Ritvik is asking, can we substitute M is equal to 15, B is equal to 11? Absolutely, you can. You can definitely substitute M is equal to 15, B is equal to 11, but I will try to play it a little safe by substituting M is equal to 11x. M is equal to 15x, B is equal to 11x. Okay, need to be a little safe, but I don't think you will go wrong in this question. Okay, you can definitely do that. So here you will get ratio M by B as 15 by 11. So wherever M is there, you can go and substitute 15. And wherever B is there, you can substitute 11. Perfectly, you can do that. That will give you in terms of number of units, you will get total work. You can use that here and then you can go forward. That's also definitely a legit way of solving this question. Okay, so I hope it's clear for everybody how we can solve this question. Let's move to the next one. The next question is up in the quiz. I'm also activating that question on the screen here. Okay, there is an alternate solution that someone has given. That's definitely a good approach. You can definitely do that. If we can rearrange and try to get the required expression, we can do that. Oh, the timer is not visible. Yeah, the time is up for this question. I did not show you the timer for this question. The time is up. Let's see the status of the leaderboard after you guys have attempted this question. Okay, I think many of you are getting it right. It's just going to be a battle of who is doing it the quickest. Let's solve this one. 4 pipes P, Q, R and S can fill a tank in 6, 8, 10 and 12 hours respectively. Pipe P was opened at 1 p.m., Q at 2, R at 3 and S at 4 approximately. At what time the tank will be filled? Okay, so let's see. Let's first take their efficiencies. So first time, that is P, Q, R and S are taking 6, 8, 10 and 12 hours respectively. So LCM of all of this, what will that be? 120? Yeah, 120 units. So if we take 120 units, then the efficiencies would be 20, 15, 12 and 10. So if 120 units is the total work, if you assume that to be the total work, then 20, 15, 12 and 10, these should be the efficiencies of these pipes P, Q, R and S. Okay, now they've given P was opened at 1 p.m, Q at 2 p.m, R at 3 p.m and S at 4 p.m. So what I'm going to do is I'm going to see at 4 p.m. what is the scene, because suppose that all of them are going to be open. So I'm going to see at 4 p.m. what is the scene. So at 4 p.m, as P was opened at 1 p.m, this was open for how long? 3 hours, right? Because it was open at 1 p.m. itself. So 3 into 20. So this would have done 60 units. P would have already filled 60 units. And the next one, Q was opened at 2 p.m. So that was open for 2 hours. So 15 into 2, 30 units. R was opened at 3 p.m. So this is open for 1 hour. So 12 into 1, that is 12 units. And S just got opened at 4. So it would not have filled anything. So if I add this up, 60 plus 30 is 90, 90 plus 12, that is 102 units were already filled at 4 p.m. Now all the pipes are going to be functional from 4 p.m. onwards. But how much is remaining? Because total was taken as 120 units, right? In that 102 is already filled. So another 18 units is remaining, but now they're going to fill at this rate, sum of all of this, because now all the pipes are open. And how much is that coming to? 20 plus 10, that's going to be 30 plus 27, 30 plus 1, 57. So 18 by 57. Right, 18 by 57. Now these are all in terms of hours, so these many hours it is going to take. So if you look at this, till 4 o'clock we have seen, but after 4 o'clock 18 by 57 hours. So if you convert in terms of minutes, it will become 18 into 60 by 57 minutes. So it should be slightly more than 18, because 60 by 57 will be slightly more than 1. So slightly more than 18, so slightly more than 418 I should have. Anyway, they're asking for approximately. We have got 419 here. That is the answer for this question. Please type 2 if you're clear with why we have got option 2 as the answer for this question. Type R if you want me to explain this once again, if you're not clear with what I explained already. Okay, someone is saying, is there some issue? My questions are starting beforehand. Okay, I can troubleshoot what's happening here. So what happens is in YouTube, when I'm doing the live session, there is around 5 seconds of lag that can be there. Okay, so as there could be around 5 seconds of lag. Now, when I say that I am going to the next question, okay, when I say I'm going to the next question and I click the next question immediately, but you get to listen to my saying I'm going to the next question maybe 5 seconds later, right? So around that 5 seconds of gap, you can definitely expect. It can even go to around 10 seconds because of up, down and all that. So around 10 seconds of difference, you can see that. You might see that, by the time you go to the window where the quiz is there, the question has already started. It is possible. Okay, it is possible. And that's why I've given a little more time for all the questions. Okay, I've given around 30 seconds extra for all the questions to make up for that. Anyway, your timer will only start once you have started the attempt. So I think that should not be a problem. Even if the question starts a little before, like 10 seconds, 15 seconds before, your timer will only start once you have clicked start attempt. Okay. Great. So does that answer your question, Aditya? Okay, Lavanya is asking how 425 is eliminated. Okay, I'll tell you how 425 is eliminated. If you look at 60 by 57, that's going to be very close to 1. It will not be too high. Okay, this is going to be very close to 1. So I will not get 425. I will get something which is only slightly more than 18. Slightly more means not 7, 2, 3 more and all that. Like maybe 19 or 19 point something, it will only go that much because 60 by 57 is very close to 1. Okay, that's why we are not even looking at 425. It has to be around 19. Okay, it should not be too much high. Okay. Okay, someone is asking me to repeat. I'm going to quickly repeat what's happening here. They have given these 4 pipes. They take these many hours respectively to fill. So I've put the hours here. I have taken the LCM of this, and that's 120 units. And what is that? I've discussed that in the concept class. This is assumed total work. Or in this case, you can say assumed tank capacity if these are all filling a tank. Okay. Assumed tank capacity is 120 units. At that rate, if each of them is able to fill at 6, 8, 10 and 12 hours, I can divide 120 by 6 and get the efficiency of pipe P, 120 by 8 to get the efficiency of pipe Q and so on. So these are all efficiencies of all these pipes. So what's happening is these pipes are getting opened sequentially. Okay, these pipes are getting opened sequentially. So P was opened at 1 p.m, Q at 2 p.m, R at 3 p.m, S at 4 p.m. So after that, all the pipes are going to be open, right? So I'm trying to find out at 4 p.m, how many units are already filled, because post that, it's always going to be all pipes. So at 4 p.m, if I see P was opened at 1 p.m, right? So it must have been open for 3 hours. So 3 into 20 will give me 60 units. So pipe P would have filled 60 units at 4 p.m. And Q was opened at 2 p.m. right? So 2 p.m. to 4 p.m. is 2 hours. So in those 2 hours, 15 into 2, that would have filled 30. R was opened at 3 p.m. So 1 hour, it must have been on till 4 p.m. So 1 into 12, 12. I don't have to calculate anything for S because S was opened only at 4 p.m. I am calculating things at 4 p.m. So 0 for S. So at 4 p.m. these many units were filled. Assumed total work is 120. So remaining is 120 minus 102, 18. And from now on, all the pipes are going to be operational. So the total rate at which they are going to fill is sum of all their efficiencies, which is summing up to 57. So I'm trying to find out remaining time taken. Time taken in time and work is work by efficiency. So work to be done is 18 units. Total efficiency is 57. If I divide this, I'll get the number of hours it will take. But the answers have minutes here. So I'll have to convert this in terms of minutes. For that, I'm multiplying by 60. And I realize that 60 by 57 is going to be pretty close to 1, but definitely slightly more than 1. So our answer should be slightly more than 18 seconds after 4 p.m. So 4 p.m. plus slightly more than 18. So 419, it cannot be 425. That will require me to increase 18 by a huge amount. It won't be that much more. It will only be a little more because 60 by 57 is going to be only 1 point, some very small value. Is that clear? Type C if it is clear as to how we solved this question. I just want to make sure that nobody is not understanding a question that we are discussing. So some of you might have to be a little patient even if you've solved a little earlier. Perfect. One more reminder, if you haven't liked this video, I don't like doing it, but I'll have to remind you, otherwise you might not end up liking the video. So please do like the video if you're liking the way the session is going. That helps us to reach more students. Okay, and if you haven't subscribed, please do subscribe. Great. Let's move to the next question. I'm going to the next question in the quiz. The next question is up in the quiz. It's up on your screen here as well. We are at question number 8. We have 10 questions for today. So after this, we will have 2 more questions. Okay, the time is up. Let us see the status of the leaderboard at the end of this question. I don't see much of a change. I think there's some change around rank 3 and rank 4. Let's see how we can solve this. Two pipes A and B can fill a tank in 8 hours and 24 hours respectively. There is an outlet exactly at 2/3 of the height above the base which can empty the top 1/3 in 4 hours. Okay, let me put the timing of all of these. So we have two filling pipes. I'm putting filling pipes as F and the leak I'm going to put as L. Okay, just for us to be very conscious that these are filling pipes and there's a leak. Pipe A and B can fill a tank in 8 and 24 hours. So in terms of time taken, it will take 8 hours. This will take 24 hours. There is an outlet exactly at 2/3 of the height above the base which can empty the top 1/3. Now this is critical, guys. Which can empty the top 1/3 in 4 hours. Now the 8 and 24 hours that I've put for the filling pipes are for filling the entire tank. So you got to understand that we're dealing with a full tank capacity here. For full tank capacity, how much time the pipes will take is what we're supposed to take. So I cannot put 4 here because the leak will take 4 hours to empty 1/3 of the tank. So if the leak were to empty the full tank, then it will take 4 into 3, 12. I'm just going to put minus 12 just to signify that it is doing opposite work. Okay. 12 is because 1/3 of the tank in 4 hours. So full tank is 4 into 3, 12 hours. Okay. Now let's take the LCM of this and assume that to be our tank capacity. 8, 24 and 12. So that will be 24 units. That I'm assuming to be the capacity of the tank. So now if I go for efficiency calculation, 24 by 8, that's going to be 3. It's going to be 1. This is going to be minus 2. Those are the efficiencies. Okay. Now the question is, then how many hours will the empty tank be full if both the pipes and the outlet are opened simultaneously? Okay. So just to visualize, let me take this. Let's say this is our tank. And I'm going to split the tank into 3 parts because the leak is at 1/3 of the height. It can empty that 1/3, top 1/3, 2/3 from the bottom. From top 1/3 down, I have the leak, right? So let me split the tank height into 3 parts. I probably have the leak somewhere here. Okay, so this 24 units, let's just split it into 8, 8 and 8. So when the empty tank starts getting filled, right, when all 3 are open, that is the 2 filling pipes and our leak are open, when the empty tank starts getting filled, till the water level reaches this stage, it is as if the leak doesn't exist. So only the 2 filling pipes will be functional. So till the 16 units, till these 16 units get filled, it will only be FA and FB which will be operational. So 3 plus 4, so 3 plus 1, 4. So it will take 16 by 4 hours only. Okay, but post this the leak will be operational. So post is how many units? Another 8 units are there, but that will be filled at this combined efficiency of all of them. So 3 plus 1, 4 minus 2. So effectively only 2 units will get filled. 4 units will get filled, 2 units will go out because of the leak. So effectively only 2 units will get filled in an hour. So 8 by 2, this should take another 4 hours. So 4 plus 4, it should take 8 hours in total. So answer is 8 for this question. Please type 8 if you're clear with how we got the answer as 8 for this question. Perfect. Looks like everybody is clear. Let's move to the next question in the quiz. The next question is up in the quiz. It's up on your screen here as well. Great, the time is up. Let's see how we can solve this one. Some of you have got it right. Very good. Let's see how to approach this one. If 20% of a certain quantity of work is done by A, and after that the remaining 80% of the work is done by B. See, it's happening sequentially. You got to keep that in mind. 20% first A does, then 80% is done by B. Then it takes 20 days. If 80% of work is done by A, and after that the remaining 20% is done by B, the work is completed in 30 days. How many days are required to complete the work if A and B work together? Okay, so let's start forming our equations for this situation. So 20% of work, so let's say it is 0.2 W, where W is the total work. So 0.2 W when A does, so I can say by efficiency of A, that's the time that A will take to do 20% of the work, right? Plus B is doing the remaining 80%. So 0.8 W by efficiency of B. Now that is going to be equal to 20 days. So I can say this is equal to 20. Similarly, we can form one more equation. 80% of the work is done by A. So 0.8 W by efficiency of A plus 0.2 W. It's given the remaining 20% is done by B. By efficiency of B, that's going to be 30. So I've just converted whatever is given in the form of an equation. Now, what are they asking for? How many days are required to complete the work if A and B work together? So basically we'll have to find out W by efficiency of A plus efficiency of B. This is how much. That's what we're finally supposed to find out. So let's see how we can arrive at that. Means I should be able to probably write EA and EB in terms of W. If I can do that, then I can solve this. Or W in terms of EA plus EB. Okay, let's see how we can do that. So looking at this, there's some kind of symmetry here, 20%, 80%, 80%, 20%. So I am tempted to add them. So if we add them, what do we get? If we add both of them on addition, I will get 0.2 W plus 0.8 W by EA, which is W by EA, plus W by EB is equal to 50. So let's put that. W by EA plus W by EB is equal to 50. But I need W by EA plus EB. Okay, so this is one relation. And we can also get rid of one of them if we want to. Right. So let's get rid of one of them. I'm going to get rid of, okay, I'm going to get rid of, let's say, W. So let's multiply this equation by 4. If I multiply that by 4, it becomes 0.8 W. And when you go for subtraction, W will go off. I will have this and the constant term. So in that case, what will happen? Let's say I am doing this process. W goes off. So it becomes 3.2 W. Sorry, EA goes off. 3.2 W by EB minus 0.2 W. That's going to be 3 W by EB. That should be equal to what? 4 into 20. That's 80. 80 minus 30. That's going to be 50. I've got W by EB already as 50. And it is also given W by EA plus W by EB is 50. I have also got 3W by EB is also equal to 50. So this 3W by EB, I can probably write it as W plus 2W by EB as 50. That tells me that W by EA is equal to 2W by EB, right? Because that's the only difference in these two equations. So if I take that relationship, that is W by EA is equal to 2W by EB. Now that tells me what will be the ratio between EA and EB. So let's get that. So let's get rid of these two. I will get EB by EA is in the ratio 2:1. Once you get EB by EA is in the ratio 2:1, you can take them as 2 units and 1 unit and then substitute here if you want. Okay, if you substitute it as 2 units and 1 unit here, you will get a value for W in terms of units. I can also substitute 2 unit and 1 unit here to get a value for W in terms of units. Or if you want, you can convert everything in terms of EB or everything in terms of EB. That is also fine. So I'm just going with converting all of them. So EB, wherever it is there, I'm going to write it as 2, let's say 2M just to play it safe, and EA as 1M. So EB is 2M, EA is 1M. So this will become 1M This is 2m. So that will give me a value for W in terms of m. So I can write that here. So W by m plus W by 2m is equal to 50. Let me just take, is it coming behind my head? Okay, let me take it here. So W by m plus W by 2m. So I can put by 2m here and it will become 3W is equal to 50. Or I can say W is equal to, this goes on the other side, it will become 100m by 3. So instead of W, I can write 100m by 3. And EA is 1m, EB is 2m. So EA by EB is 3m. Now I can cancel the 2 m's. I will get 100 by 3 by 3, which is basically 100 by 9. So that should give us the answer for this question. Okay, this is one of the ways to approach. I'm sure there should be multiple ways to approach because most of it is algebra that's happening here. You're playing things by moving things left, right. So once you've got this, the time and work part is actually over. After that, it's all about just adjusting your equation to get the required expression. But throughout, you should have an idea as to what you're heading towards. Are you trying to convert everything in terms of one variable, or are you trying to convert everything in terms of EA or EB or W? So if you keep a track of that, you will be going towards the right direction. Please type 5 if you're clear with how we got 100 by 9 as the answer for this question. Perfect. Let's move to the next question, guys. That's going to be question number 9. Out of the, oh, we are already done with question number 9. We have only one question left. So we are looking at the last question for today's quiz. The last question for today's quiz is up in the quiz. It's also up on the screen here. Assume that they finish work P and then go to work Q. Okay, the time is up. let us check the final state of the leaderboard after all the questions for today. Congrats, Swati on top, followed by Subhashish, MSD, Bhargav, Sandeep, Abhishek, Pranay, Gaurav, Bharat, and Ravi, Raman, Sharat. Congrats to all of you guys who ended up on the leaderboard. Let's see how we can solve this one. Work P can be completed by A, B, C in 20, 15 and 30 days respectively, and an amount of rupees 4,000 is paid for that work. Another kind of work Q can be completed by A, B and C in 15, 20, 25, 10 days respectively. So that's a different work. That's why you see that the ratio is not the same, the time taken ratio. And an amount of this much is paid for this work. If A, B and C work together, first on work P and then on work Q, who got the minimum amount of the three? Okay, so let's take each one of these work separately. So work P, for that, the time taken in terms of days is 20, 15 and 30. Similarly, I can track for work Q also. A, B and C. Time taken is 15, 25 and 10. So let's get efficiencies, because generally money is split. Okay, the leaderboard is still there. Let me just get the leaderboard out. And probably just explain this once again. I don't want to have the leaderboard while we are discussing something. Okay, so let's look at this. So there are two different works given, right? Work P, for which they take some time, and the work Q, for which they take a different set of time. It's given that it's a different work. That's why you don't see the same ratio, right? And two amount is given, 4,000 and 10,000. We have to find out who got the minimum overall, if they're going to first work on P and then go to Q. So let's track both of them. So work P, A, B and C. It's going to be 20, 15 and 30 days. Similarly for work Q, A, B and C, it's 15, 25 and 10 days. As money is generally split in the ratio of their efficiency, let's try and calculate their efficiencies here. So 20, 15 and 30, I can probably take 60 as my LCM, right? 60 units. If I take as the assumed total work, then the efficiencies would be 60 divided by 23, 60 divided by 15, 4, 60 divided by 30, 2. And in this case, what LCM can we take? 15, 25 and 10, 150. 150 should be fine. 150 is divisible by all of them. So 150 divided by 15, that's going to be 10, 6 and 15. So these two works are there. Definitely they are two different works. That's why you see that their ratios are not constant. Their efficiency ratios are not constant. Right. Now, for this work, they were paid 4,000. For this, they were paid 10,000. We'll have to find who got the minimum amount of the three. Okay, let's first just compare B and C. Okay, so B and C, if I see here, B has got double of what C has got when the total amount of money that's getting split is 4,000. But C has got more than double of what B has got when the money that is getting split is a much bigger value. So from these two, I can conclude that C will definitely have overall a greater amount of money with him than B. Let me quickly explain that once again. Here, if you see, B has got double the amount of money, but then the money that is getting split is very small. Here, if you see, C has got more than double of what B has got, and the money that is getting split is also big. So definitely the amount of extra money that C is going to get here will more than make up for the difference in the money here. So definitely C is not the answer, because we are looking for who got the minimum amount. So C is ruled out already. So C is not going to be the answer. It could be A or B, or if both are getting equal, we'll have to figure that out. Okay, so C is not the answer. Now I'm just going to compare between A and B. Okay, let's look at A and B over the C. if I see here B, or let's look at A gets 25% less than what B gets, right? 25% less, or you can say A gets 75% of what B gets when the money that is getting split is 4,000. But if you look at this, B is getting only 60% of what Q is getting when money that is getting split is 10,000. So that loss of pay that B has with respect to A is going to be a bigger value because the money that is getting split is also big and the difference here is also pretty big. I mean, if you're keeping A as the base, there is a 40% difference here. Okay, but if you see here, that much of a difference is not there. Okay, so there is, if you keep A as the base once again, you will only see that there is a 33% increase. Or if you see where the advantage is, this guy has got 75% and this guy has got 100%. So the 25% is the difference when the money that is getting split is 4,000. Here, if you see, if I take this as 100%, this is only 60% when the money that is getting split is 10,000. It's a much bigger value. So definitely the difference that B has here is more than the difference that A has here. Hence, you can conclude that B is going to have the least amount of money in this whole deal. So answer for this question is B. Please type 1 if you're clear with how we got the answer for this question. Type R if you want me to repeat once again. Of course, you can find out what is the exact amount they are going to get, but that's going to take a little longer. If you see what we did here, by looking at the ratios and the total amount that is getting split, we are able to make decisions quickly. So that way you'll be able to solve this question quicker than actually finding out what is the value that these guys are going to get. Okay, great. So with that, we have come to the end of the discussion. I hope you guys liked the questions. Did you like the questions that we had today? Type yes if you enjoyed solving the questions that we had in today's session. See, I am assuming that we have to solve all these questions without calculator. Someone's asking, can be done with calculator? Can this be done with calculator? Gaurav is asking. This can be done with calculator, but my target is to make sure that we are ready for solving a question like this for any exam, even if they are not going to allow us calculator. Right? So even without calculator, we should be able to solve this question. And if you follow the logic that we were trying to do here, it can definitely be solved without calculator, even with a lesser amount. Okay, great. So if you haven't liked the video, please do like the video. I'll catch up with you guys in the next session. See you guys. Good night. I understood, Gaurav. You are asking whether this is to be done with a calculator, right? Yes. If calculator is there, we can do. But I wanted to make sure that we also try without calculator. Okay. Great. Good night, guys.